Hey people, we're doing another recap and again with matrices, and we're going to look at the associative law and the distributive law as it applies to matrices. And just letting you know, in this video, lowercase r and lowercase s are real numbers, alright, scalars they're sometimes called, and capital A and capital B are matrices in this video. Now we know for real numbers, so if we have real number A multiplied by B by C, if they're associated like that, so the brackets around the B by C, we know that it's actually equal to A multiplied by B in brackets, then multiplied by C, so for real numbers. Okay, and we can apply associativity, this property, how they associate with each other, to matrices as well. Alright, so we're going to look at multiplication of a matrix by a scalar R and then S and see how that works. Okay, and so if we have a look at the following, R times S times matrix A, we could consider that as, not that we need to write this down, but we could go R times S then multiplied by matrix A, and that actually equals R times the product of the scalar S and the matrix A. Okay, so they are all consistent with each other, give the same result. So this associativity in such a case with multiplication holds for matrices. So this is termed associativity. It's how they associate with each other. The order does not change. Okay, the positioning of the brackets changes. How about the other one, the distributive rule? We know of just regular old real numbers, A outside of B plus C equals AB plus AC. They call the distributive rule. You would have seen that. Or we could write it, maybe this is a little more unusual, but we know we can actually write it like this as well. And with real numbers, these results are the same, even if we're talking about what we do in an algebra topic, okay, in junior high school. We know they're the same. We know that works as such with real numbers, but for matrices and scalars we may have seen, and if not we will see, that two scalars R plus S distributed about over addition distributed about matrix A gives RA plus SA. Okay, so that's distributivity over addition. Okay, distributivity over addition. Alright, so we're calling on our distributive law at the moment, distributivity. Alright, butivity. Alright, and we have another property. If we look at, so we had two scalars and one matrix. If we have one scalar and two matrices, assuming they can be added, alright, remember addition of matrices, they have to be the same dimension, A and B. That would be R times matrix A plus R times matrix B. Alright, and we've probably seen that. We've probably done enough questions now to see it. This is a recap of all of that. Okay, so scalar multiplication over matrix addition holds. Okay, so that's over, I guess I could put scalar addition in the first one, and this is over matrix addition in the second pattern I just showed. Okay, over matrix addition, but they hold. Alright, so scalar multiplication over matrix addition and scalar multiplication over the scalar addition hold for distributivity of matrices. So whenever you do questions like this, look out for associativity and distributivity.